In this example, we will solve a linear congruence with the help of Chinese remainder theorem. Let's write it down. X is congruent to 2 in modulus 3. X is congruent to 3 in modulus 5. The X is congruent to 2 in mod 7. The first thing we need to do is to just calculate the product of the modules, those modules product. So our product will be 105. Then we are going to calculate the M1, M2 and M3. Here's how we are going to do it. The product will be divided by its mod. We'll have 35 here. M2 will be M divided by 5. This will be 21. And the M3 will be M divided by 7. This will be 15. The next thing we do is we say that 35 times x1 is congruent to 1 in mod 3. First, we will need to reduce this. So it will, in mod 3, 35 will be 2. Because when we divide 35 by 3, we will get 11 with the remainder 2. So, in mod 3 world, 2x1 will be congruent to 1 in mod 3, and x1 will be congruent to 1 times 2 minus 1, the inverse of 2. To calculate the inverse of 2, that is very easy to do. We just need to divide 3 by 2. When we divide it, we will have 1 with the remainder 1, right? Or we may write 3 is equal to 1 times 2 plus 1, and 1 will be equal to 3 minus 1 times 2. So basically we can claim that 2 is our coefficient. That is why x1 will be congruent to 2 in mod 3. 2, the inverse of 2 will be 2 as well in mod 3 by using Euclid's algorithm. Then we go on. 21 times x2 is congruent to 1 in mod 5. x2 will be congruent to 1. We did the same process. We divided 21 by 5. We got 1 with remainder 1. Here we'll have 15 times x3 congruent to 1 in mod 7. The same process goes on here as well. In the end, we'll need to calculate the x, which will be the sum of all the x's, m's, and y's multiplied together. This means that we will have to sum 35 times 2 here, 35 times 2 times 2 plus 21 times 3, because we got 1 over here, and plus 15 times 2. We will get 233, and we will write 233 mod 105. In mod 105, if we divide it, the remainder will be 23. So we will write down that as 23. So our x will belong to 23 plus 25 times k, and the k will belong to the set of integers.